Okay, so welcome to the quiz correction for Algebra 2. Problem number 1 says, write an equivalent expression to this expression given that x does not equal 3, x does not equal negative 2, and x does not equal negative 3. So when they're asking us to write an equivalent expression, they're actually just asking us to simplify this by doing whatever operation they want us to do, and put it in its slowest term. So that means make sure there's nothing that's can be canceled out still. So when we're multiplying, we're essentially going to end up with one large fraction, because when you multiply fractions, you just multiply straight across the top. So you can think of this as x squared minus 2x minus 3 being multiplied by 3x plus 9 all over x squared minus x minus 6, x plus 3. Now, when I'm looking at it right now, it doesn't look like there's anything I can cancel out. So that should be my cue that I need to factor some things to see if maybe I can find some factors that will cancel out. So when I'm looking at x squared minus 2x minus 3, I'm looking for two numbers that multiply to give me a negative 3, but when I add them, I get a negative 2. Now we've been having a lot of difficulty with factoring, okay? So automatically, if this number right here is negative, then I automatically know one of my factors has to be negative and the other one has to be positive. And the way I determine which one's negative and which one's positive is based on this number here. So because my b value is negative, I know the larger number here has to be negative. There's only one way for me to get 3 by multiplication, and that's multiplying 3 times 1. And again, I know my larger number has to be negative because I need to end up with a negative after I add. So negative 3 plus 1 is going to give me that negative 2. So I'm left with x minus 3 times x plus 1. If I look at my second item, I don't see any x squares there, but I do see with my numbers, they have a number in common. This means I can factor out a 3. So if I factor out a 3, then what's left inside is x plus 3. If you're ever unsure about what goes in here, you can, in your head or on a scratched piece of paper, distribute it back in and make sure that you're getting what you started with. Now let's move on to the denominator. Here I'm looking for two numbers to multiply to give me a negative 6, but when I add them, I get a negative 1. Okay. So again, I know my numbers have to be a positive and a negative number because that's the only way I'm going to get a negative product. So here, I know this is a negative 3, sorry, it's not writing, a negative 3 and a positive 1, sorry, positive 2, because 2 times a negative 3 will give me a negative 6, but when I do 2 plus a negative 3, that will give me a negative 1. So here I have x minus 3, x plus 2, and of course we still have our x plus 3. And so now I'm looking for items that can cancel out to make this a simpler expression. So I'm going to start in my numerator, and I'm just going to compare my terms in my numerator to the terms in my denominator. So x minus 3, I see I have one here, so it cancels out. X plus 1, there's no x plus 1, so it stays. 3, there's no 3 by itself, so it stays. X plus 3, there's an x plus 3 here, so it cancels out. So what we're left with is 3 x plus 1 all over x plus 2. And I would have accepted this as your final answer. Okay, let's take a look at problem number 2. Problem number 2 is the same type of problem as problem 1. It says write an equivalent expression to this expression given that x does not equal 2, x does not equal negative 8, and x does not equal a negative 3. So again, if I actually do the multiplication here, then we'll have one long fraction, x squared plus 3x minus 10 times x plus 3, and x squared plus 6x minus 16 times 2x minus 6. And again, I don't see anything immediately that we can cancel, and because of that, I'm going to then look to see if I can factor some things out. So looking at the top term, I need two numbers that multiply to give me a negative 10, but when I add them I get a positive 3. So I know, because of factoring rules, that this is a positive 5 times a negative 2. 5 times negative 2 will give me negative 10, and 5 plus negative 2 will give me a positive 3. So I can rewrite this as x plus 5 times x minus 2 times x minus 3. And I do the same thing for my denominator. I'm looking for two numbers that multiply to give me a negative 16, but when I add them, I get a positive 6. And so this would be a positive 8 times a negative 2. 8 times negative 2 gives me negative 16, but 8 plus a negative 2 will give me a positive 6. So we're left with x plus 8, x minus 2. And now let's look at our last term. Again, I don't see any square here, so it doesn't look like it's going to break down into two terms like two factors like these did. But I look at the numbers 2 and 6, and I know I can pull out a 2. So when I pull the 2 out, I'm left with x minus 3. And again, if I wanted to check if this is correct, then I can do some distributive property in my mind. 2 times x gives me 2x. 2 times negative 3 gives me negative 6, so that works out. So our last step here is to cancel out anything that cancels out. So I start in my numerator, the first term, x plus 5. There's no x plus 5 in the denominator, so that stays. X minus 2, I find an x minus 2 in my denominator, that cancels. X minus 3, I find an x minus 3 in my denominator, and that cancels. So what we're left with is x plus 5 over 2 times x plus 8. So here's the 2, here's the x plus 8. I would have accepted this as your final answer. If you went the further step, you would have ended up with 2x plus 16. Problem number 3 asks us, for what values of x is the expression undefined? So in order to answer this question, we need to know what it means for an expression to be undefined. So specifically, a fraction is undefined when the denominator equals 0. So that means our focus for this problem is going to be on the denominator. So I believe in this problem, if you showed that you were focusing on the denominator, I gave you some partial credit, even if you didn't really go anywhere meaningful with it. So this means I know that I'm looking for when x squared minus x minus 2 is going to equal 0. So this is a quadratic expression equal to 0. So this is something you should have learned and practiced a lot in Algebra 1. Okay. Now the way that you saw when a quadratic expression equal to 0 is you factor it out. So that means we're looking for two numbers we can multiply to get a negative 2, but when we add them we get a negative 1. So again, right now I know that one of my numbers has to be positive and one of my numbers has to be negative. I know my larger number has to be negative because I end up with a negative sum. So I know this is minus 2 and plus 1. Because 1 times a negative 2 is going to give me a negative 2, but 1 plus a negative 2 will give me a negative 1. So now the reason that we factor is because when we factor, it allows us to use what is called the zero product property. The zero product property basically says if you have two things, one thing, two things, being multiplied together and their product is 0, then you know that one of these two things has to equal 0. So that means it lets us break this down into two equations. X plus 1 equals 0 or x minus 2 equals 0. We solve these two simpler equations for x. And we find that our denominator is going to equal 0 when x equals negative 1 or x equals negative 2. And so if we look back at our question says, for what expressions of So for what values of x is the expression undefined? So we can say the expression is undefined when x equals -1 or 2. This is the final answer I was looking for. Okay, so question number 4 says, is this expression defined for the value of x minus x equals -2? Show and explain why or why not. So again, if we want to determine when an expression is defined or not defined, we are looking at the denominator because we know a fraction is not defined when the denominator is equal to 0. So I'm going to set my denominator equal to 0, and I'm trying to figure out whether or not this fraction will be defined for the value of x equals -2. So again, when you have a quadratic expression equal to 0, the way that you solve these problems, which you should have learned in Algebra 1, is to factor the expression into its two factors. So I'm looking for two numbers that multiply to give me a -12, but when I add them I get a -4. And this is -6 and +2. I have x minus 6 and x plus 2 equal to 0. This is because -6 times 2 will give me -12, but -6 plus 2 will give me a -4. So now once I have this set equal to 0, again, what I'm using here is called the zero product property. Which is essentially saying that if you are multiplying two items or more and their answer is 0, the only way that can happen is if one of these things already equals 0. So that allows us to set up two simple equations, x minus 6 equals 0 or x plus 2 equals 0. So I know x equals 6 or x equals -2. These are the values. These are the values that will make my denominator equal 0. Which means these are the values that will make my fraction undefined. I'm going to say that again. These are the values that will make my denominator equal 0, which means these are the values that will make my fraction undefined. And the question was, is this expression defined for the value of x minus 2, x equals -2? Well, since it's one of the values that will make my fraction undefined, I know this is not true. So I can say, no, this expression is not defined for x equals -2. Now this is one way that you could have answered this question. There's also another way you could have answered it. Since I already know that they want me to check x equals -2, what I could have done is I could have just plugged in this x equals -2 to my denominator and see if it gave me 0 or not. And some of you did do this. So I have x squared minus 4x minus 12. I could plug in -2. -2 squared minus 4 times -2 minus 12. And I get 4 plus 8 minus 12, which is 12 minus 12, which is 0. So what we just saw here is that when I plug in -2 for my x in my denominator, it makes my denominator equal 0. And when my denominator equals 0, that makes my fraction undefined. So again, we can say, no, this expression is not defined for x equals -2. The reason is because -2. Problem number 5 asks us to write an equivalent expression to 2x over x minus 3 plus x plus 1 over x minus 2. So essentially what they're asking us to do is to add these two terms and to simplify if possible. And we should remember from adding fractions, they need to have like denominators, and in this case they don't. One of the denominators is x minus 3 and the other is x minus 2. So we're going to set our common denominator as x minus 3. times x minus 2. And so now we need to multiply both of these fractions so that they actually have this denominator. So if I'm looking at this first fraction, I have x minus 3. I want x minus 3 times x minus 2. So I know I need to multiply by x minus 2. So this ends up giving me, if I distribute, I get 2x squared minus 4x over x minus 3, x minus 2. Plus, looking at our second fraction, right now I have x minus 2. I want x minus 3 times x minus 2. So I need to multiply by x minus 3. And here I need to FOIL. So I get x squared plus 3x plus x plus 3 all over x minus 3, x minus 2. So now I'm going to combine like terms as I add these two fractions together. I have 2x squared plus x squared, so that gives me 3x squared. I have negative 4x, and then I have plus 3x and plus x. So this ends up being 4x. So I have negative 4x plus 4x that cancels out. So then I'm just left with plus 3 at the end. And this is our final answer. Okay, problem number 6 is asking us to do the same thing. Write an equivalent fraction to these two fractions being added together. So essentially what they want us to do is to actually add these together. And in order to add any fractions together, you need them to have a common denominator. And at the moment, they do not have a common denominator. So we are going to create a common denominator through multiplication. So the product of these two denominators will give us our common denominator. So now we go about, what do I multiply by these fractions so they actually have the common denominator? So my first fraction just has x plus 2, but I want it to have x plus 2 and x minus 1. So I need to multiply by x minus 1 so that it will match. So on the top, I'm going to FOIL this out. I get x times 2x, so that's 2x squared. I get x times negative 1, so that's negative 1x. I get negative 1 times 2x, so that's a negative 2x. And a negative 1 times a negative 1, which is a positive 1. And this is all over x minus 1 and x plus 2, my common denominator, which I got from multiplying those two on the bottom. Now looking at my second fraction, I just have x minus 1, but I want x plus 2 times x minus 1. So I need to multiply this by x plus 2. Whatever I do to the bottom of a fraction, I have to do to the top to make it stay equal. So on the top, I can distribute this in, and I get 5x plus 10 all over x minus 1, x plus 2. So now we can combine like terms. I have 2x squared. I don't have any x squareds over here, so I keep my 2x squared. I have a negative 1x, negative 2x, so that's negative 3x. And over on this side, I have 5x. So negative 3 negative x's and 5 positive x's leaves me with 2 positive x's. And last but not least, but I have plus 1 and plus 10, so that's plus 11.